Hi everyone, in this video I will be helping you complete the Aleks topic called Solving a System of Linear Equations Using Elimination with Multiplication and Addition. So we are given two equations, and since the method we're supposed to use is elimination, that means that our goal is to add these two equations together and get either the x or the y to cancel. So we are going to have to use multiplication in order for that to happen, because if we were to add them as is, nothing would cancel. We've got a 9x and a minus 5x. We've got a 2y and a 3y. No canceling, but that's where the multiplication comes in. So we can either try to get the x to cancel or the y to cancel, and sometimes there may be a little advantage to canceling one versus the other one, but the method is going to be the same. So in this example, I'm going to get the y's to cancel. And in order to do that, I need them to be the same value, which right now they're not. One's a 2 and the other is a 3y, but I also need the signs to be different. So I've got a 2 and a 3. As long as I multiply and turn them into the same value with different signs, then they'll cancel whenever we add. So that means that what I'm looking for is the lowest common multiple of 2 and 3. So the multiples of 2 are 2, 4, 6, 8, etc. The multiples of 3 are 3, 6, 9, and so on. And we can see here that the lowest common multiple is 6. So what that means is that I should be able to turn each one of these equations into an equivalent equation, but turning these values into 6's. So in order to do that, I'm going to multiply this top equation, the entire thing, both the left side and the right side, by a 3, because I know that that will turn the 2y into a 6y. And then on the bottom equation, since it's already a 3y, I'm going to multiply it by a 2, but remember I also want them to cancel, so I'm actually going to multiply by a negative 2. Now, distributing the 3 on the top, 3 times 9x gives us 27x. 3 times the 2y gives us a 6y. 3 times the 18 gives us a 54. Doing the same thing on the bottom, negative 2 times negative 5x gives us a positive 10x. Negative 2 times 3y gives us a minus 6y. And negative 2 times negative 10 gives us a 20. And remember, our goal here was to get these y's to have the same value with opposite signs, because now when I add these two equations together, this positive 6y and minus 6y are going to cancel. And we would be left on the left-hand side with 27x plus 10x, so 37x. And on the right-hand side, 54 plus 20, 74. And now that we've eliminated one of those variables, since we only have the x remaining, it's easy to solve for x. Here I just need to divide both sides by 37, so that on the left-hand side, the 37's cancel. We're left with just the x. And on the right-hand side, 74 divided by 37 is 2. We now have half of our answer, x equals 2. But in order to find the solution, we also need to know what the y value is going to be. So to find that y value, I'm going to go back here to our original equations. We could work with either one, so I'm just going to choose the top equation. And I'm going to replace the x with this value 2. So I'm just rewriting the top equation. That's 9x, but x is 2, plus 2y equals 18. And now we have an equation with only the y value. so we can solve that. First, doing the multiplication, 9 times 2 is 18. Bring down the 2y and the 18 on the right-hand side. Now, getting the y by itself means subtracting over this 18. And we're doing this so that it'll cancel on the left-hand side, but it also happens to cancel on the right-hand side, which leaves us with just a 2y on the left and 0 on the right-hand side because everything canceled. And from here, we can continue to solve for y by dividing both sides by 2. Those 2's cancel, leaving me with just y equals, on the right-hand side, 0 divided by 2 is 0. So we have our solution. The x value is 2 and y is 0.